Hello learner, today we are going to look at trigonometry. Now trigonometry, we are going to look at the geometry concerning the triangle. Now suppose you have the triangle ABC, which is a right angled triangle at B, and we have angle theta at C. Now we want to label the sides. The side opposite angle theta is AB, which we call the opposite side. The side adjacent to angle theta, BC, is adjacent to angle theta. Then we have the hypotenuse. The three common ratios we have of trigo: sine theta is equals to opposite side divided by the hypotenuse. Then the cosine of theta, cos theta, is given as the adjacent side over the hypotenuse. Then we have the tan theta given as the opposite side over the adjacent side. So we have an acronym for the three ratios of a right angle triangle. We call it the SOHCAHTOA acronym. The sine of angle theta is opposite of hypotenuse. Cosine of theta is adjacent of hypotenuse. Then tangent of theta is opposite of adjacent. Now these ratios are very important when we use various problems in mathematics to solve them out and to simplify various expressions. Consider this example. Given that sine x equals to 5 over 13, find cos x and tan x. Now, to solve for this, you are required to have your right-angled triangle, ABC. And you know that the sine of x, let this be angle x, is equals to opposite SOHCAHTOA. We are applying SOHCAHTOA. The sine of x is equals to opposite of hypotenuse. From the ratio here, the opposite is 5 and the hypotenuse is 13. So we can find BC using Pythagoras theorem. And we know that using Pythagoras theorem, to get BC, we'll take the square root of hypotenuse squared minus height squared. That is 169 minus 25. Get the square root, giving us the square root of 144, which is 12. Therefore, BC is 12. From there, you can get the cos of x. The cos of x, from SOHCAHTOA, the cosine of x is, the cosine of angle x is given as adjacent of hypotenuse. So the adjacent side is 12 over the hypotenuse, which is 13. Solving for tan x is given as the tangent of x from the SOHCAHTOA ratio. From the SOHCAHTOA ratio, the tangent is equals to opposite of adjacent. So we come to the triangle here. We know the tangent of x is equals to opposite of adjacent. So the tan x is given as 5 over 12. For example, given that sine x minus 10 degrees equals to cos 3x plus 20 degrees, find the exact value of tan 3x degrees. To solve this, you have to remember that the sine of an angle y is equals to the cosine of the complementary angle, 90 minus y. So implying that sine of x minus 10 degrees is equals to cos 3x plus 20 degrees. The two angles are complementary. So we say x minus 10 degrees plus 3x plus 20 degrees add up to 90 degrees. Now with this, it is easier for us to solve for the value of x. Now you add up the like terms, x plus 3x, which is 4x, minus 10 plus 20, you get plus 10 is equals to 90 degrees. 4x is equals to 90 degrees minus 10 degrees. 4x is equals to 80 degrees. Divide by 4 both sides and you get x is equals to 20 degrees. Once you get the value for x, it is now easier for you to solve for tan 3x degrees, which is the tan of 60 degrees. 3 times 20, 60 degrees. Feeding that in your calculator, the tan of 60 degrees, or you can use your mathematical table, the tan of 60 degrees is the root of 3. Let's consider the ratios for special angles: 30 degrees, 60 degrees, 45 degrees. These are some of the special angles we have. Now let's consider using the equilateral triangle ABC of side 2 units each. And we drop a perpendicular bisector here at point M, which is dividing BC into 2 equal parts, 1 unit, 1 unit. Now, to get AM, we use Pythagoras theorem, that is our height. AM, it is the square root of the hypotenuse squared minus the base, which is 1. That is the square root of 4 minus 1, which is the square root of 3. So we have the height as the square root of 3. Now, to find the angle 60, the sine of 60 degrees from this triangle of ours, SOHCAHTOA, we are still applying SOHCAHTOA. If you're keen, we have ABM, a right angled triangle. So applying SOHCAHTOA, the sine of 60 is opposite over hypotenuse, which is SAD 3 over 2. Now this is 90 degrees. This angle is divided into 2, that is 30 degrees. Now we can still get the cosine of 60 degrees. Cosine of 60 degrees is equals to adjacent over hypotenuse. Adjacent 1 over hypotenuse. And then the tangent of 60 degrees is given as opposite over adjacent. SAD. Considering angle 30, the sine for 30 degrees from this table of ours, the sine 30 is here, is opposite over hypotenuse, SOHCAHTOA. Opposite is 1 over hypotenuse 2. The cosine of 30 degrees is equals to the adjacent side to the angle 30 degrees, which is SAD 3 over hypotenuse, which is 2. And then the tangent of 30 degrees, is equals to opposite over adjacent, 1 over SAD 3. Now coming here, this is 90 degrees, this is 45 degrees, this is also 45 degrees. Still using SOHCAHTOA, the sine of 45 degrees from our triangle here, sine of 45 is equals to opposite over hypotenuse, which is 1 over the hypotenuse, which is SAD 2. The cos of 45 degrees is equals to adjacent over hypotenuse, which is 1 over SAD 2. Then the tangent of 45 degrees is equals to opposite over adjacent, which is 1 over 1, which gives you 1.